Okay, this is grade 12 pre-cal, lesson 5.3, solving exponential equations. So let's look at example number 1 here. We're trying to solve for x, and 3 to the x, we have an exponent. The problem is, if you look at 3 and we look at 81, they're not the same base. But the key to this is, can we create them so they have the same base? Well, yeah, we can change 81, right? You know your exponential law, so 3 times 3 times 3 times 3 will give you 81. So we can write it as 3 to the 4. Well, now that's interesting. If we have the same base now, we can just take the exponents, right, x and 4, right, and just make them equal to each other, so x equals 4. Okay, so the key is get a single power expression on each side of the equation. So we're talking about make sure they're the same. Make sure you have the same base on both of them, and then you set the exponents equal to each other. So here's a good example. Solve for x. Now we've got 4, and the exponent is x plus 1, and we have 1 over 32. Well, obviously they're not the same bases. But notice that 4 and 32 are powers of 2. So what we can do is we can take this 4 and change it to 2 to the 2. There it is right there, with our exponent still at the top of x plus 1. And 1 over 32 can be changed to 1 over 2 to the 5. Well, now the problem is the 2 is down the bottom here, so we got to bring it to the top. And this one, we got to get rid of the brackets. Well, that's easy. You can distribute the 2 to the x under the 1, so you end up with 2x plus 2. And over here, you know that if it's down the bottom, it was probably a negative exponent, so it was 2 to the negative 5. Now, we have the same base. You can grab the exponents, which is 2x plus 2 equals negative 5. It's just a straight equation there. Rearrange, get rid of the 2 and divide by 2, and x is negative 7 over 2. So it's really not that difficult. The hard part of this is finding the same base on both those. Okay, flip the page, and let's go and look at the next one here. So what we got here is we've got 1/8 to the x plus 1, and we have cube root of 16 to the x. Oh, okay. So you got to look at this. We've got 8 and 16, so probably our number we're working with is a 2, our common base. Well, this one's pretty easy. 1 over 2 cubed. Yeah, to the x plus 1, and then we could keep going down with this one, and it's going to go, remember, 1 over 2 to the cube, or 2 to the 3 would be 2 to the negative 3. Yeah, and then we can distribute that negative 3 to both of those. This one's a little trickier. Now, if you remember back in earlier grades, you can take the cube root of 16 and write it as 16 to the 1/3. Just like if it was a square root, you can write it as 16 to the half. So 16 to the 1/3, and then we can take 16 and break it down to 2 to the 4. It doesn't matter because the 1/3, you're raising a power to a power, so 1/3 times x is 1/3 x. So then we end up with 2 to the 4. Well, what do you do with this 4 and this 1/3 x? Well, you multiply them together. So you end up with 2, negative 3x minus 3 equals 2, 4 over 3x. Now, in the same base, so you can take the exponents and just set them equal to each other. So here it is here. An equation. Well, how do we deal with this? Well, you know, if you want to get rid of the denominator, if you multiply everything by 3, that'll get rid of the denominator. So negative 3x times 3, negative 3 times 3, and 4 over 3 times 3. So then you can rearrange everything, and you find out x is equal to negative 9 over 13. It's really not that hard. The hard part is finding the common base. Okay, now I just want to introduce the compound interest formula, because what's going to happen is we're going to eventually use this when it comes to exponential equations. So the compound interest formula is really simple. A equals P, open the bracket, 1 plus R over N to the NT. So you got to know what everything is. A is the final amount, which includes the interest earned. So for instance, if you had $1,000 and you earned 200, right, your A would be 1,200. Principal, P, is the starting amount. So if you invest $1,000, that's what P is. R is the rate, so let's say 5%, it has to be as a decimal, so 0.05. N is the number of compound periods. So if it said compounded monthly, your N is 12. Annually, N is 1, daily, 365. So you're going to have to know those ones, like even weekly, right, 52. And that N there, underneath the R, is the same N that's the exponent. So the only other one is T, and T is time in years. So we're going to come back to this equation later on, and I'll show you how to use it, the formula, and actually be able to calculate for any one of these pieces using exponentials and eventually logarithms. Okay, so that was lesson 5.3.